Okay, so today we're going to talk about what we didn't talk about in the last video, which is a different method for graphing from standard form. And basically, this different method just comes from noticing a pattern when we're completing the square to switch from standard form to vertex form. And the best way to look at this pattern is to actually just complete the square or switch from standard form to vertex form without using any actual numerical values, just using our A, B, and C values in our standard form, which I know gets confusing, but this should only take like a minute or two if you watch and pay attention. Hopefully it'll make some sense how we're deriving this formula that we're going to use today. So the idea is, again, we have our standard form of a quadratic function, and it's any quadratic function. So ax squared plus bx plus c, where a, b, and c are any values. So we're going to switch this standard form, where a, b, and c are any values, to vertex form. And to do that, again, we're going to pretend like we're completing the square. So I'm going to make f of x 0. I'm going to get 0 equals ax squared plus bx plus c. The first step is to move our c value over, so I get negative c equals ax squared plus bx. Then, because I have an a value, I need to factor that a value out. So negative c is going to be equal to a factored out times x squared plus, well, when I factor out a from b, I get b divided by a times x. And now I need to complete the square. So I'm going to take half of that value, my linear value. So b over a divided by 2 is really b over 2a. And this is the point where I'm going to square it. And whatever I get when I square it, I'm going to now multiply it by that a value to add it to the other side of my formula. However, we don't really need to go through all that, because from doing completing the square so many times, we've already figured out, right, that this value, the linear term, when I divide by 2, that's what winds up being in my squared binomial. That's what's going to wind up being h, right? And the h in my function, the h in my vertex form function, f of x equals a times x minus h squared plus k, that h is negative, meaning my x value of my vertex is always going to be negative b divided by 2a. Right? This value, this linear term divided by 2, is always what h is, and h, the negative of h, is always my x value. So I can figure out the x value of my vertex of any quadratic by just using the formula negative b over 2a. And if I figure out the x value of my vertex to find the y value, well, to find the y value of any function, if you're given the x value, you just plug it in. So as soon as I know negative b over 2a is my x value, I know my y value is going to be whatever f of negative b over 2a is. So to find my x value, I do negative b over 2a. When I get that value, I just plug it right into my function. That's going to tell me my y value, and now I get my vertex without having to use the completing the square method. Okay, so now we have a way to find the vertex of a quadratic function in standard form without going through the whole completing the square method. And we also know what the vertex form of a quadratic looks like, so that should basically be enough to switch from standard to vertex without going through all those steps from the last lesson. So if we look at number 1, we see that my a value in front of x squared is just 1. My b value is negative 4. And my c value is positive 4. Which we don't really need right now, but we know it, so we might as well write it down. So anyway, to find the x value of my vertex, my little formula that I figured out is that the x coordinate is going to be negative b divided by 2a. My B value is currently negative 4, so negative of negative 4 is positive 4. And then I'm going to be dividing it by 2 times my A value of 1. So 4 divided by 2 times 1 tells me 4 divided by 2 is 2. So the x value of my vertex is 2. Once I know the x value of any function, I can plug it right in to find the y value. So that's what I'm going to do. I'm going to take 2 and plug it in. So f of 2 equals 2 squared minus 4 times 2 plus 4. So here I get 4 minus 8 plus 4. 4 minus 8 plus 4, that's just going to be 0. So f of 2 equals 0, meaning my vertex is at 2, 0. Now that I know my vertex, I can now write this equation in vertex form. So vertex form is f of x equals a times x minus h, which is the x-coordinate of my vertex, squared, plus k, which is the y-coordinate of my vertex. So if I plug that all in, f of x equals a, my a value was 1, so I keep my a value of 1, times x minus the h value is the x value of my vertex, so minus 2, all squared, plus my k value, which is the y value of my vertex, which is just 0, so plus 0 isn't going to do anything. So here is my function in vertex form. Similarly, if we move on to the next example, if I want to find my vertex, I use my little formula, x equals negative b over 2a. In this case, my a is 2, my b is 12, and my c is 19. So with b being 12, my formula, x equals negative b over 2a, is going to be negative 12 divided by 2 times my a value of 2. So it's really negative 12 over 4. So x is negative 3. Now I want to find the y value of my vertex, so I just plug that x value right in. So f of negative 3 is going to equal 2 times negative 3 squared plus 12 times negative 3 plus 19. So f of negative 3 is going to equal 2 times negative 3 squared. Negative 3 squared is 9, so 9 times 2 is 18. Plus 12 times negative 3, which is negative 36, or minus 36 in this case, plus 19. So 18 minus 36 is negative 18. Negative 18 plus 19 is just 1. So f of negative 3 equals 1, meaning my vertex is negative 3, positive 1. Once I know my vertex, again, I write out my vertex form, f of x equals a times x minus h squared plus k, and now I can just plug in all my values. So f of x equals a, which a from my original function is 2, so it's still going to be 2, times x minus the x-coordinate of my vertex, so minus negative 3 is going to be plus 3 squared, and then plus k. K is the y value of my vertex, so positive 1. And there is my vertex form of this exact same function that I started with. So f of x equals 2x squared plus 12x plus 19. In vertex form is f of x equals 2 times x plus 3, quantity squared plus 1. Now if you wanted to check this, you could technically write out x plus 2 squared as x plus x plus 3 squared as x plus 3 times x plus 3, multiply that all out, multiply the 2 to everything, and then add 1 and combine like terms, and you should get back to f of x equals 2x squared plus 12x plus 19, because these are both the same function. They're just a different way to write the function. This way of writing it is more useful for finding the y-intercept and for solving by factoring to find the x-intercepts, and vertex form is more useful for knowing the vertex. Okay, so now it's your turn. Give these two practice problems a try. Pause the video, try them out in 5 seconds. the video will unpause automatically and I'll show the answers. Okay, here are the worked out solutions. For problem number 3, you should have got x equals -3. You plug it in and you get -1, so your vertex is -3, -1. So when you go to write it in vertex form, your a value from the original function was 1, so you get f of x equals 1 times x plus 3, right? Because your x-coordinate of your vertex is -3, so minus h is going to give you +3, quantity squared, minus 1, because your h value is the y value of your vertex, -1. For number 4, you should have got x equals -2 when you plugged into negative b over 2a. Plug -2 into your function, and you get 4. Your vertex is -2, 4. So when you go to write it in vertex form, f of x is going to equal -3, your original a value, times x plus 2, quantity squared, plus 4. Okay, so let's take a look at how we might use this in practice to actually graph a function without having to do all the work from the last lesson. So I'm given f of x equals -x squared minus 8x minus 15, and I want to graph that. And I'm going to graph it by finding the vertex and finding the x-intercepts separately instead of using the completing the square method. So to find the vertex, we use our little trick, x equals -b over 2a. So we get negative of -8, that's my b value, is +8 over 2 times my a value, which is -1. And we get 8 divided by -2, which is going to be -4. Now that I know my x value is -4, plug it in. F of -4 equals -4 squared minus 8 times -4 minus 15. So -4 squared is +16, but then it's negated, right? So you get -16. Then we have -8 times -4, which is +32. And then we're also subtracting 15. What we wind up with is f of -4 equals +1. So the vertex here is going to be -4, +1. My vertex is at -4, +1. Now, before we go to look for the x-intercepts, it might be useful to also know the y-intercept. The y-intercept is right in my function. It's this -15. It's my c value, right? Because if I plug in 0 for x, these will both cancel out, and I'm just left with -15. Now, the graph is not big enough for me to graph -15, but if I could graph -15, also knowing the axis of symmetry would give me 2 more coordinates for this graph. But like I said, the graph's not big enough right now, so unfortunately we cannot graph that. Now, once we know the vertex, we also want to find, at least 2 more coordinates to plot, especially because we can't plot the y-intercept, so we're going to try to find the x-intercept. So to find the x-intercepts, we make y 0. So 0 equals -x squared minus 8x minus 15. And now we can use a c method to solve for our x-intercepts here. So a times c in this scenario is +15. The b value is -8. So what adds up to -8 that multiplies to +15? That's going to be -5 and -3. Replace my b value. I get -x squared. Equal to 0. -x squared minus 5x minus 3x minus 15. Group my first two, group my last two. In my first grouping, a -x factors out, and I'm left with x plus 5. My second group, a -3 factors out, and I'm left with x plus 5. So my two factors are -x minus 3 and x plus 5. Set them equal to 0 separately, and I'm going to get that x equals -3 and -5. So I plot my x-intercept -3, plot my x-intercept -5. They're both equidistant from the axis of symmetry, which makes sense. And now I can sketch my curve with confidence. I notice that my vertex is a maximum, right? So I have a maximum at -4, +1. This is a parabola, so that means the domain is all real numbers. The range is going to be -infinity to my y value of my vertex, which is 1. The y-intercept, as we figured out before, was my c value, so that's 0, -15. And then it asks for the solutions. Remember, solutions is just another word for x-intercepts, just like roots, right? Solutions, roots, x-intercepts all mean the same thing. So I'm going to write my answers to when I found the x-intercept was -50 and -30. So hopefully you found this lesson useful. Again, this is just another way to graph from standard form. If you liked what we did in the last lesson with graphing it from using completing the square, that's totally fine. This is just another method for you to have in the back of your mind in case you're having trouble solving it in that way.